You are watching Tech and AI Live. Now we have a great presentation coming up with Lisa O'Connor, Managing Director at Accenture. Her presentation is titled Getting to Trustworthy AI. Lisa is the global leader of security research and development at Accenture, leading 2 labs in Washington, D.C. and Herzliya, Israel. Her role is to ideate, develop, and co-innovate with Global 2000 companies to create the future of security and cyber defense. Through her work, she protects the Global 2000 companies, critical infrastructures, and advances the industry with her focus on cyber innovation. Key to her success, she looks over the horizon at the global startup ecosystem, protecting cyber capabilities and strategic investments for future co-innovation and go-to-market strategy. So welcome, Lisa. It's great to have you here.
Thanks. It's so wonderful to be here.
Brilliant. So why don't we get straight into it, because I know there's a lot of content to get through.
There is a lot to get through, and very excited to go through it. And we are going to talk about getting to trustworthy AI and what that means. And first, I wanted to give you a little bit of background on myself. I am part of Accenture Labs, which is an exciting group within our technology innovation ecosystem that really looks out at applied research. And so we look at the theoretical and we look at the art of the possible. And we actually take those techniques and apply them, do proof of concepts, prove them out, and really see what value they can bring to both Accenture and to Accenture's clients. And the exciting part is I'm in cybersecurity, and we actually have a whole R&D group that is dedicated to AI. But I look at AI a little bit differently, and you'll start to see what that looks like throughout our presentation. But I'm really happy to be here for this journey. Trustworthy AI is now a name out there in the industry that we can talk about. We've been doing research in it for 4 years, and we've been developing techniques for not only attacking AI and figuring out how it breaks and how this whole process works, but also how to defend it. And this is a really important business challenge. So we're using AI. I mean, you can look at all of the tech. It's an incredibly growing field. Most companies are using it actively for all sorts of insights and business processes. But the number of companies that are actually using it in a trustworthy way, applying the techniques and things that we're going to talk about, isn't large, and that's a concern. And so there's a business risk in here. And it's important to cyber people because cyber people think about, what does my attack surface look like? How do I defend the network? How do I defend apps? How do I defend sort of the space that is the enterprise and the cloud? And part of that is, how do I defend AI? How do I know what new risks I have? And cyber defenders call that the attack surface. Where is the company exposed, and how do we tighten it up so that we're confident in it? And this is super important for people that are developing AI, for data scientists, and for how we're thinking about AI to use in business insights. So this community, and what kinds of things we should be doing throughout that journey of AI to protect it. And so my goal, hopefully, is to kind of expand how we think about AI and what the importance of getting it to trustworthy is. All right, so trustworthy, in the way we think about it, is really has 3 components to it. So we think about responsible AI as sort of the first part, which we'll think about, fair outcomes, ethics, accountability, and maybe even some sustainability things in there too. The second part is we talk about as robust AI, and by robust we mean resilient, resistant to attacks, that it's safe, that it's confidential, that it's tamper resistant, and secure with appropriate lineage around the data in and the insights out. Explainable AI is something many of you who are familiar with GDPR know that that's a requirement within GDPR. If you're using it for a process that's in scope, you have to be able to explain how you got the insight or the outcome that you did. You have to know what triggered it and be able to support that with robust information. And what's really interesting is if you look at, sort of the financial statements, the 10Ks and the annual statements of Fortune 500 companies, many of them are talking now about the risk of AI. And we saw, I think it was a 20% increase I'm sorry, 46% increase year over year about how many mentions AI is getting, but 20% increase in the number saying, yes, we're using more AI and we're concerned about the risks. So this is really definitely a C-level concern, and it's actually a board level concern for shareholders. So very important that we get it right. And what I'm going to share is just a little bit of a primer. Most of you already are well aware of all this, but we'll just do some framing on machine learning and artificial intelligence. And as many of you know, machine learning isn't one thing, it's many things. There are many different algorithms that we would consider in the family of machine learning. And again, machine learning is wonderful if you have good data and you can understand the data and you can get insights out of it based on what you know, classifications, relationships between the data, maybe understanding the proximity of the data to some other element. These are all great applications for machine learning. And deep learning is a little bit different. Vast amounts of data. You may not know a lot about the data, but it learns in a similar way to how the brain kind of functions, sort of this layered approach. And there's not a lot of hands-on with machine learning, right? It's a little bit what we call a black box in the sense of putting things in and getting things out. But it does give us some amazing insights. So the part that I wanted to share and emphasize is that there is a whole field of adversarial AI, where it's really the methods, if we think about how AI is being attacked and why. So again, it takes advantage of some of the complexity of machine learning and deep learning. And it actually, the things that we can craft, we can do it in an automated way, which also sort of ups the prevalence of it. But these attacks will pass a human test. They'll pass sort of the inspection and the other things that we may put in place to understand if there's been a change or if somebody's tampering with your model. But they have major effects on the outcome of the ML. And we'll talk about what some of those effects could be. And Accenture published a paper in Adversarial AI, which goes into tremendous detail about the methods, the outcome, which kinds of attacks work on what kinds of ML and algorithms. So we'll do a little bit of a primer on the machine learning ecosystem, because this is how cybersecurity kind of think about the world. We think about the processes, we think about attack surface, and we think about this whole training period. And so machine learning is part of an ecosystem where you have participants that want an outcome and they have participant data that they may all be submitting. And then there's a model developer or a service provider that's doing your model development that is actually looking at the data, potentially labeling it, doing things with the data to create model and model outcomes that satisfy the customers, the users. And the users are going to be eventually training the model, saying, yes, good insights, good confidence, and we'll step through that. But this ecosystem is important because it's very much like the application's development lifecycle. And that's how we really need to think about it. So the training phase is really the phase where you're extracting the story from the data. And this is so important because the data rules all insights. And again, we have an entire data set. We have to think about where we got it from. We break that out into a training data set and a testing data set. We put it through our machine learning algorithm, and we come up with a classification model, right? So a model that's going to give us an outcome or an insight that we've asked for. The second part of that is the inference phase. And this is really, as we think of kind of the run phase in production, where the model is put into production, and now it's the time for the insights. There may be feedback to the model that comes back in, where it could be supervised learning or input back in to retrain the model. And then the classifications come out, right, with certain confidences that meet the tolerance of the business owners for that. And in this case, we're using an example of imaging to do a diagnosis based on an image. And have an outcome of what that image could be. And so we have many examples. If you want to think about sort of the generic, you have object in action. It could be some pre-processing that happens. You apply the model and you get output. Same thing, whether it's, computer vision in a car, as we're thinking about reading stop signs or yield signs or understanding what's going on. And there's an output action, and there may be an automated event like putting on the brakes. We have examples from cybersecurity, especially in like network detection or other things where we're trying to automate and keep up with the speed of the attacks and being able to identify malware or identify when there's something happening in transmission or packet files that we don't like. So the way we think about it is thinking about the entities that can act, the security attacks on the system. And we think broadly about who the attacker could be. And sometimes this is knowingly purposeful attackers, and sometimes this is sort of unwittingly, maybe not being careful or having good hygiene or other things around the data that could introduce risk to the data. And so if we think about the attacker on the training phase and the inference phase, we have participants, and as we looked at our life cycle, participants that are giving us data. We have the server, the system on which we're doing the training. We have the developer who's doing the training, who's actually hands-on with the model. And in the inference or run phase, we have the server where the model is situated. And we have the users who are pushing data to the model to get insights out. And this is really important. The victim, if we look at the sort of vertical column there, we have many sort of different dimensions of victims, whether it's a participant, and usually that's more on the privacy side. We'll get to that next. The server, the developer, the user, we can look at them as the one that's been acted upon too. And so this is a really, this is an important, way to kind of break up and think about the attacks, because it lets us get our heads around who can act on who and how do we think of the risk at different stages. And one of the biggest attacks that, biggest potential, and I think Gartner also said that too, that in 2022 we expect 30% of the attacks to be data poisoning attacks. And data poisoning is where you're modifying or injecting data into the training data to bias the model to make it detect something or not detect something as the adversary may want in this cycle. And so you can imagine ingesting training data that somebody gets into your training data set that actually can corrupt or trigger something on the output that you didn't discover in the journey of training the model. And so you can see where some of these attacks can get quite exciting. And the other kind of privacy attacks on AI systems that I mentioned are also important, and they're also tied to cybersecurity because we think about those as data privacy or data confidentiality, making sure that only the authorized people have access to that data. And in the example that we had, we talked about imaging data. And so imaging data, healthcare sensitive, all kinds of regulations come into play with healthcare data. So it becomes very important to protect that data. And so if we think about the healthcare data and participant data leakage, what would we do? We want to protect the data, yet I want to share it so that I can train on it. And I might have different people in that pipeline of model development that I trust or not trust. So I might want to participate, but I might not want to fully share my data with everybody. There are techniques to protect your data, like privacy preserving, homomorphic encryption, federated learning, federated split learning, all these techniques that let you encrypt your data and share it so that it can be operated on in a machine learning environment. And there are limitations to it. So, full disclosure, but there are ways of doing this in a protective way so you're not at risk for some of that participant data leakage. And these attacks that I'm talking about, one of the good references is the MIBR attack framework. And MIBR has created a special framework for machine learning, which help us understand these attacks. And the thing I want to draw your attention to in the MIBR attack framework is this top row going across: the reconnaissance, resource development, initial access, ML model access, execution, persistence, defense, evasion, discovery, collection, ML attack staging, exfiltration, impact. That is the kill chain. That is how an organized adversary will go through and advance an attack on your model and on those systems. And they're really important to break down in these stages because at different stages, you have different techniques that those attackers are going to use to advance to the next level. And sometimes we'll find that adversaries will stay in the reconnaissance resource development stage for a while and just watch. And other times they'll prosecute very quickly down the kill chain. It depends on your adversary. But this kill chain is really important in looking at some of these techniques that are lying underneath. And so I think the question that we have is if an ML algorithm is attacked, compromised, or data is breached, would you hear a sound in your event logs? Would you know it? And that's the biggest question I think we have now as model developers, as data scientists, as cybersecurity people. Are we listening for the right things? And just to let you know that security is not immune to this. Security actually has had some of the more publicized attacks. And some of these are performed by researchers just to demonstrate that it's possible. And others, they had some help from friends. So again, there have been model evasion attacks on tools like Cylance and Palo Alto. And Cylance is a good example because, again, their whole raison d'etre is to identify malware. So if I am an attacker and I want my malware to get through the defenses, how do I train the model? How do I inject things into the model so that I can evade detection? And that's what they actually demonstrated is true. And there are other examples of this on different cybersecurity software platforms. But I think that the other thing too is that in neural networks, when we think about deep learning, it's probably an even bigger challenge because we have huge data sets. And what is in those data sets? And I think, one of the examples that just came out is that an attacker could hide in about 20% of that data, and you probably wouldn't know it because of the nature of the way neural networks work. And that's kind of a staggering thing that 20% of your data might not be good and may be able to trigger some kind of a reaction that you didn't want. So, what's the answer? One of the things that we need to do is really double down on threat modeling. And so, if threat modeling is a new term and you haven't thought about this with your AI, this is super important. The threat modeling is a team sport. And this is something where you should pull in developers, you should pull in the business, and you should pull in your cybersecurity folks to join together to think about this. And one of the good ways to start with threat modeling is to start with distrust. Distrust in the process, because really your trust is earned by getting through this process and really building robust AI. And data sources, as I mentioned, are critical. And so think about it. Imagine the last model that you worked on, and you got data sources. People pointed you to the data sources that were going to be used for your training. Do you know where it came from? Do you know how it was collected? Do you know what it was collected for originally? What was the purpose that they collected that data? Was there a chain of custody on the data where you had confidence that you knew how it was handled and protected throughout its life cycle? Is the data sensitive? Is it regulated? Is it under a regulated industry like financial services or healthcare? The important thing here is if you can't answer these questions with great confidence, you really need to assume it's compromised or poisoned because it's probably highly likely. So data stewardship, understanding what your risks are, maybe even running through some depoisoning is a very important practice. And the other thought too is we have so many models now that are sort of off the shelf, if you will, that we get jump started on. Are you building your model from scratch, or are you buying that as a service or some foundational piece of the model as a service? And this is important too, because you want to make sure you understand how that model works. You want to understand how it's getting to the insights that it is, not that you're just getting the insights. The how is important. And in industries where explainability is required, you're going to have to explain how. But the big thing that I think this team sport can do with pulling the right folks together is understand the motivations of the threat actors. And the business has an important role in this because the business is going to know what's valued, what's important about this business decision. Why would somebody come after it? Is it a loan decision? Is it a healthcare decision? What's behind the decision, and who would be interested in changing or modifying that decision for their benefit, or just to disrupt. And AI threat scenarios could harm the business, but you even have to think bigger than the business. So you think about what harm could come if this model breaks bad, if you will. What happens to the business? How could it affect business processes? How could it affect customers? And depending on what service area you're in, how could it affect citizens, right? And so thinking of those scenarios of how could your model do harm, very important. And then the countermeasures piece. What countermeasures can you put in place and where in the life cycle to reduce the risks? And this is, again, where your cybersecurity folks, your model developers, your data protection folks can really help in that life cycle. And who will be accessing the model? Like when you put it in its inference phase and it's out into production, who's the intended audience? Is it an internal business owner, or is this something that is serving an external function where it is actively going to be receiving data requests, all sorts of things from the outside? That's important too, to sort of the threat scenarios that you're going to be up against. And as we talked about that tree falling in the woods, who's monitoring the model for anomalous behavior or inferences or attack activity? And it's interesting because this really is a shared responsibility. I don't think any cybersecurity folks can help understand whether the expected behavior is or isn't to spec with the inferences and the outcomes that the business wants. That's what the business has to help with. And the cybersecurity folks can help with what are the things that we can be monitoring for or to reduce that risk profile so that we will know when something, when there is an attack in progress or there's something happening. And at Accenture, we developed internally a testing suite to do this. You can dig more into this, but it literally goes through the kinds of testing, making sure that the models are robust. And you can see some of the questions and some of the countermeasures that we put in place. And this is to prevent from model extraction, manipulation, compromise, secret stealing, all sorts of stuff. But the big opportunity here is with ML, it comes back around. And it's always coming through the DevOps lifecycle. So even if you don't have these in place now, take the opportunity at the next training, take the opportunity at the next cycle of development to get those controls in place. Thank you.
Thanks so much, Lisa. That was really interesting. And we do have some questions. We've had quite a few coming from the audience, but we might have time to do one, maybe two. So I'll start with this one. It's on the metaverse. It's something people are always big on asking. So how much of what we know about trustworthy AI can be used in the metaverse? What changes in the metaverse should there be for expected AI attacks?
Yeah, it's a great question. So a lot of where I think the business started in looking at models and defending models was on what was more traditional business data. So it was columnar data, text, all sorts of things. But if we think about the metaverse, what we're going to be seeing there is a lot more video streaming, real time, as we get to the most immersive experiences. And those are different data types. And so again, making sure that the defenses apply to those data types and they work in the same way. We did a little bit of work with satellite imagery, making buildings hide in plain sight, which was kind of a fun sort of data poisoning and depoisoning exercise we did, where we could show that we could change the models. And I think most folks might be familiar with an adversarial patch attack, where you can hide in plain sight right in front of a camera by holding the right kind of graphic enough to disrupt the model so that it doesn't detect you. Stunning things. So I think things like that, we're going to have to go a lot farther to be able to meet the real experience of the metaverse in real time.
Okay, brilliant. Thank you. I mean, I think we'll have time for one more. So I've got this one. This one seems like it might be a bit of an easier one to answer. Why haven't we seen more on AI and ML attacks in the wild?
Excellent question. And it's funny in doing the research, it is probably where we are in that life cycle, right? Of getting these controls in place, getting the monitoring in place. And that's why, we take the approach distrust and then earn the trust, because these are probably already in progress. We are not hearing, the numbers that everybody expects. And Gartner's already sort of put their foot in the door saying it's going to be 30% of the attacks are going to be data poisoning, because we're not looking. And we need to be looking and listening for these and making sure we're instrumenting our business processes, our systems, our applications to watch for these attacks.
Brilliant, brilliant. Thank you so much, Lisa. It's been really interesting. It's always a good topic of mine that I like to learn about cyber and AI. I think we could speak for hours on it, but sadly, we've only got half an hour, so we are going to have to wrap it up there. But thank you so much for taking the time for joining us today. We really appreciate it.
Great. Thank you so much. I've really enjoyed it.
Thank you. And obviously, thanks to the audience for watching. And make sure you stay tuned to check out the rest of our speakers at Tech and AI Live.